Hello everyone and welcome back to the channel. In today's video, we are going to be taking a look at how you can automate your financial analysis by using Agentic AI and how you can build your custom financial analysis agent using Langgraph and the reflection pattern. So stay tuned till the end. By the end of this video, you will understand the core concepts of Langgraph, how to build your Agentic AI custom agents using Langgraph, and also how to do your financial analysis or automate your financial analysis by using Agentic AI. So stay tuned to the end. In my previous video, I had shown an entire example on how we can automate your business analysis using Langchain and a custom code interpreter. If you haven't seen that, do take a look at that as well. And let's dive right into the code. But before we dive right into it, do not forget to subscribe to my channel for the latest of data analysis across different technologies. So before we dive into the code, I would like to give a small overview of the kind of the automation that we're going to be building using Langgraph. So let's take a look at the same. Okay, this is your architecture or your flow that you're going to be build using a Langgraph, and Langgraph helps you visually design your entire flow using nodes and conditional edges and edges, and this helps you represent your functional flow and helps you build complex agentic AI agents, which will actually help you solve very complex business tasks. So in this case, you can see here the workflow starts at the start, and you and basically in this workflow, the user is going to give the agent a complex business problem or a financial problem, and the financial analysis agent is then going to solve the problem. Okay, so how is going to do that? So you can see that the graph, the first node, so node are basically functions that are called in the graph. So the first node takes in the prompt, and this financial analysis node calls the LLM and does the financial analysis as a financial analyst. Now, it does certain calculations and it may have some mistakes or it may have some errors in the math. So we do not give the output directly to the user. We pass the output, especially for complex financial problems, and we'll take a look at that in the solution. So the output is then passed to the financial expert review. The dotted line here represents something called as conditional edges. Basically, from the financial analysis node, it can branch either to the financial analysis expert review node or to the end node. So here it's going to iterate. So the financial analysis expert is a chain which does the review of the analysis generated by the financial analysis chain. So whatever is the output of the financial analysis chain, the financial analysis expert chain reviews it, critiques it, and then it gives the suggestions and improvement areas, or if it finds any problem in the math, back to the financial analysis agent. And this process keeps on repeating until the financial analysis agent is sure that all of its calculations are accurate and the math is accurate and the analysis is accurate. Then it will branch off back to the end node and the output will be given to the user. So let's take a look at this step by step in code. All right. So if you have not installed these packages, then do install these packages because you will need them to run the code and then you can follow along. I'm using a Jupyter notebook for the same. So you can use Langchain, install the Langchain OpenAI, Langgraph, and Gandalf. Okay. So let's see what these different packages do. So first, we have the chat prompt template and the message placeholder. So these are from the Langchain underscore core library, and this will basically help you construct your chat prompts. Okay, if you have experience in Langchain, you will be familiar with that. If not, do let me know, and I can make a videos on those as well. Then you use the chat OpenAI. So basically, this class helps you chat with your LLMs and your different kind of OpenAI models. Use .env function to load your environment variables where you keep in your OpenAI key and the other environment variables that you would be required to use for connecting with your LLM models. Your human message class helps you configure the human message, which is then going to be passed to the Langgraph. And finally, you have the message graph class from Langgraph. So let's see how do we do it step by step. So I've loaded the libraries and I've also loaded my environment variables. So first I need to instantiate the chat OpenAI class. I instantiate the chat OpenAI class. Okay, I use base URL here because in case you have deployed your LLM at a custom endpoint, you can access that. You can ignore this if you are using the standard OpenAI endpoints. It will directly point to that. Then I have loaded my Open API key. You can get this from OpenAI. Okay, OpenAI API key, then the model I'm going to be using is the GPT-4o, and the temperature I've set to 0 because I want high accuracy, especially when I'm doing financial analysis. So now let's take a look at the generation prompt. Okay, so as we mentioned, in the reflection pattern, we have something that will do an action and another kind of a chain that will review that action. So here we are generating the analysis. As I mentioned, the financial analyst will generate the analysis. So let's see what this chain does and what is this prompt. So the from the chat prompt a template dot from messages. Okay, I'm going to write this message. This is going to be a system message. Okay, and then this is the prompt. So I'm telling the LLM that you are a financial analyst and you're going to be solving a financial problem. Do it in a step-by-step manner and explain your reasoning. So the analyst will not only do the analysis but also explain his reasoning. This is very critical because, as we mentioned, we just don't want the output, but we want the output to be reviewed. So if the output is done in different steps, then only the reviewer can review it and check for accuracy. Okay. Now we're going to create a reflection prompt that is going to be used by the reflection chain. Okay. So we can see again here, same thing. We have used the chat prompt template, and again this is a system prompt, and here we are telling the LLM that in this case, for this chain, you are a seasoned finance expert. So the LLM will assume the persona of a financial expert, and he's going to and the LLM is critically going to examine and validate the steps of the calculation. Not only that, we're also going to telling the LLM, take a look at the math. Okay, because not only the steps, but the math has to be accurate because these are financial problems. So the accuracy needs to be very high. So we are instructing the LLM that take a look at the math and ensure that any mistakes in the steps and the math is corrected. Okay. If the answer or the working seems wrong, you need to give suggestions. So it will tell the, again, it will tell the financial analysis chain that you have made some mistakes and correct it. And this iteration will keep on going on until the answer is correct. Okay. So then we have done a very simple. So let's run these two. Okay, let's run these two first to make sure everything's working fine. Okay, it's working fine. Okay, then we just pass these two prompts to the LLM. Okay, so you can see the generation chain and the reflection chain. We have piped them to the LLM. This is the pipe operator. We have piped them to the LLM. Okay. Now we also create the function. As I mentioned, the nodes are different functions we call in Python. So we need to create these functions before we can assemble them using your graph, or we can assemble the workflow using the graph. So this is the generate node function. So basically we have nodes as we have seen, and nodes are nothing but functions, okay, that execute some code. And this generate node is the financial analyst. If you remember in the Langgraph visual representation as we saw earlier, right, in the workflow. So this generate node does nothing but it takes in the state. So every time a message comes, we maintain the state because we want to have a collection of all the messages so that the context is built for the LLM to improve every time and time again. So this generation node takes in the state, okay, and then it invokes, okay. So the generation chain, it invokes the LLM, and whatever message it is passed back to the state. So as I mentioned, the entire state of the messages keeps on getting maintained. So we have build the context. So let's execute this. Okay. Now the reflect node, again, as we saw, this is another node. This is working as the review expert, okay, the financial expert who is basically going to review. So the reflection chain, and we saw that prompt earlier. So the reflection chain, now this is invoked again, okay, it executes the prompt, and whatever message is returned is passed back to the state. Okay, so again the context of the messages are maintained, and it will check the output of the generation node, and it will ensure that if any mistakes are there, it is pointed out and it is noted. Okay, as I mentioned, we also have the iterate node. So here in this case, we'll keep on doing the iterations until a specific counter has been achieved. We can also have specific conditions upon which we want to branch. Okay, so this is used for branching, basically for your to implement your conditional edges. So now we are going to build the graph here. For building the graph, we are first going to call the message graph class. We instantiate the message graph class, and then we'll add one by one each node, as we saw in the presentation. So first is the generate node. Then we add the reflect node, and for the generate node, the generate node function is called. For the reflect node, the reflect node function is called. Then we're going to add the conditional edges, okay, as we saw from the generate. So the generate basically is the financial analyst. It can branch off. Okay, so we are calling the iterate function here. Okay, and we have seen the iterate function. until the count of 2 is achieved. So that means 2 iterations, it will keep on iterating. Okay, so that is the condition. So it can branch off to the either the reflect node, and once the iterations are complete, it will branch off to the end node. So these are the two branches. Okay, so it can and this is the conditional edge, so it can branch off to the reflect node until the iterations are complete, and once the iterations are complete, it will branch off to the end node. That means the process is complete. And finally, once it is at the reflect node, so it will branch back to the generate node. So as we saw in the diagram, okay, let's take a look at the same. So we can see here, it can branch off here till the iterations are complete from the financial analysis. It can branch off to here the financial expert review or the end node, but from the financial expert review node, it can branch, it can go only to the financial analysis node. So this is a normal edge, and these are conditional edges. Okay, and finally we set the entry point. So the entry point is the generate node. So let's execute this. Okay, now we compile. So now we have put the graph together, we have created the nodes, we have linked the nodes, we have given the conditional edges. Now let's compile the graph. Okay, I'm going to execute this small bit of code. This is nothing but just to visualize what kind of graph we have built. Okay, and that matches with the workflow that we have designed in the presentation. So let's run this. Okay, so you can see here, it shows it's starting at generate. Okay, from generate, the dots, you can see this reflects conditional edges. It can either go to end or it can go to reflect until the iterations are happening. But once it reaches a reflect, it will go back to generate. So it will keep on happening from generate to reflect and reflect to generate until the iterations are complete. And once the iterations are complete from generate, it will go back to end to the end and give the reviewed and correct result back to the user. So you can see this is the visual representation. So now this is the prompt. Okay, this is the financial analysis which I want to do. So say I have a financial analysis problem and I ask my analyst to solve it. Okay, so I would say John is a t-shirt vendor, and I'm not going to be breaking down this problem. Okay, I have already modeled this like using Excel. I made a lot of videos on Excel. So if you want me to explain this problem, how I solve it in Excel, do let me know, or you can refer my channel for a lot of videos on linear regression, logistic regression, and business analysis using Excel. But basically, the problem statement says that John is a t-shirt vendor, okay, for a specific team, and there's a fixed cost, there's a variable cost, and there's a price that will be charged only until a week after the tournament. So there are complex business rules, okay. And finally, we want to know that what is like we know what is his demand, okay. This is his demand, and he is thinking of ordering 14 50 shirts. Okay, so we have a lot of complex rules in this, and we want to build a financial model to tell us what is the profit of this vendor for different combinations. Okay, so if I had to model this in Excel, I'm not going to explain in detail, but I would model this by something like that. I would calculate the cost, the fixed cost, the variables, what is the full price, then what is the price that has been reduced after a specific time, as we saw in one of the rules, and then what is the shirts ordered and what is the demand. Okay, and you can play around with this and then find out what is the total profit. So say as we saw in the problem, he's ordered 1450 shirts and the demand is 1500. So there are different rules set as to what to take as the number of shirts sold. If the number of shirts ordered is lesser than the demand, then we take the number of shirts sold as the number of shirts ordered. But if it's more than the demand, then we will take the demand. So again, all these complex rules are there, which is modeled in Excel. But now we want to see how we can automate this using Agentic AI. Okay, so this is the prompt. Okay, now let me execute this prompt and see how it does. Now it will take some time, as you can see, because it is going to iterate multiple times. It is going to generate, then it's going to review the result. Once the review is passed, any correction will pass back to the generator, and then again it will see, the analyst will see if it needs to make any changes. Okay, so this is the output. Let me copy this and let us analyze this output in a text file. Okay, let me paste it here. Okay, so you can see here. So we can see here, this is the human message. So basically, this is the first message that is being generated by us. Okay, so when we have invoked it, this is the problem statement that has been passed. Okay, and you can see now what has happened is Langgraph has generated the AI message. So the AI message basically is nothing but the analyst who is now generating the solution based on the prompt. Okay, so whatever it is broken down the steps. I'm not going to explain this, but it is broken down the steps, is reasoning, and it told what is the cost, and it has finally found the cost as 13,000. I'm sorry, it has found the total profit as total revenue minus total cost, which is $13,750. Okay, and now it will pass back this to the reviewer. Okay, so if you see here again, and I'll explain this in a second. Let us find the human message again. Okay, let me search here. Okay, so now we have another a human message, and I'll explain this later. So basically, this is again the financial expert who we have asked him to personate as a financial expert. It is going to re-evaluate the problem for accuracy and assumptions. Okay, it's going to check that. It's also going to check the math calculations, and it'll if it finds any errors, it is going to again pass that back to that. So it has checked it. It has found it correct, and it has given a feedback that the calculations and the assumptions appear to be correct, and this is passed back to the again the financial analyst, which finally takes it and compiles the total output again. Okay, so once it has been reviewed, now it will also show that the total profit for John is 13,750. Okay, so let's take a look at this in the Excel. We can see here the total cost, the total revenue, and the total profit is 13,750. Now let's play around with something. Let's see if I change this dynamically, if it's going to work. Say I'm going to increase the number of shirts ordered to 1,600. Okay, and in this case, if the demand is 1,500, but the number of shirts ordered is 1,600, let's see what my number of shirts sold. Okay, my number of shirts sold will still be 1,500, as even though I've ordered more shirts, if the demand is only 1,500, I cannot sell more than the demand. Okay, so in this case, if the number of shirts sold is if the number of shirts ordered is 1,600 and the demand is 1,500, the profit is 14,050. So let us take a look at this. I'm going to modify the prompt here. So let's say the number of shirts. Okay, the demand is 1,500 still, and the number of he's thinking of ordering 1,600 shirts. Okay, so let us run this. And now we'll see again, because it's going to recalculate for the new numbers in the problem statement. Okay, so it's actually doing the math for you. It is also actually reviewing the math for you, and is also reviewing the steps, and it is giving the output. So you can see how accurate this is. Copy this again. Okay, let's paste this here. Okay, and now you can see the human message. Okay, and let's see the AI message, and let's see the output. Finally, it's found the answer as 14,050. The total profit is 14,050, which is correct with our Excel sheet as we had seen before. Okay, and again now the reviewer will review it. Okay, let's search for human again. Okay, again it's going to reevaluate and review, and finally the AI message will be generated again. Okay, by the analyst, and it will give the final output. Okay, which you can see here is 14,050. Okay, now let me explain one thing. You'll say, how is the human message coming? So basically, this is actually, we have done a trick here. Okay, the generate node is generating the AI message. Okay, and the reflect node also is generating the AI message, but so that we have a clear visibility on the flow, I have tricked it to show that this is actually a human message. So I have tricked the AI to interpret that this review is being done by a human and not an AI. If you want to remove this, you can remove this as well. It will show as AI message, but I just wanted to show that if a human was doing the review, how it would look like. But here we have completely automated, where the analysis is also done by the AI and the review also is done by the AI. I hope you enjoyed the video. If you did like the video, leave a comment on any other doubts you have, or any other videos on agentic AI principles or Langgraph or Langchain you want me to make. I've also make a tons of video on data analysis in Excel. If you like those and you want any videos on that, do let me know. Do subscribe to my channel, leave a like and a comment on the video. Thank you.